The question says that a body of mass 2 kg initially at rest moves under the action of an applied force of 7 Newton on a table with a coefficient of friction of 0.1. Now compute the work done by applied force in 10 seconds, and also work done by friction in 10 seconds, and work done by net force on the body in 10 seconds, and change in kinetic energy of the body in 10 seconds. So we have to find out the work done by this force for the duration of 10 seconds. So let us start with the diagram. Assuming that this is the box, the body of 2 kg, it is on a table with the coefficient of friction of 0.1. So mu k, that is kinetic coefficient of friction, and the horizontal force of 7 Newton is applied. And also, since the body would be moving in this direction, so the displacement is going to make an angle of 0 degree with force. So according to this expression, F cos theta d, where d is the displacement and F is the magnitude of force and cos theta is the angle between force and displacement, theta, this cos theta is going to be 1. So it can be explicitly written as Fd, that is the multiplication of magnitude of force and displacement. Now force of friction would be acting in this direction, so we can represent it by Fr, and Fr has a magnitude of mu times the normal force, and here normal force is the weight, so 0.1 times normal force would be 2 multiplied by 9.8 meter per second square. So it will come out to be 1.96 Newton. So according to force equilibrium, the net force that would be acting on the 2 kg body would be 7 Newton minus 1.96 Newton. F net, magnitude of F net would be this, and that will be equal to 5.04 meter per second square, 5.04 Newton. Now in order to find out the displacement in 10 seconds, we need to have acceleration. Now acceleration is defined as force divided by the mass. So force here is 5.04 Newton divided by mass, that is 2. Now this will give out the acceleration, that is 2.52 meter per second square. So we have acceleration now, that is 2.52 meter per second square. So we can use this acceleration and with the equation of motion, that is ut plus half at square, s equal to ut plus half at square, to find out the displacement, where s is the displacement in the direction of acceleration. So using this expression, the displacement s would be equal to ut, since u is equal to 0, the body is starting from rest, so 0 plus half times a, that is 2.52 times t square, duration of 10 seconds, so it would be 10 square, and that will give us a magnitude of displacement as 126 meter. Now the first part of question says that work done by the applied force in 10 seconds. So applied force here is 7 Newton. So work done by this 7 Newton force is equal to 7 Newton multiplied by 126 meter, and that is 882 joule. Now B part of the question says that work done by friction in 10 seconds. So we found out that friction is 1.96 Newton. So work done by frictional force is, now the work done by frictional force would be negative because the angle between frictional force and the displacement is 180 degree. So theta equal to 180 degree and cos theta is negative for 180 degree. And also we can see it intuitively that frictional force is opposing the direction of motion, so it is going to be negative. Now frictional force is 1.96 Newton, and displacement is again 126 meter, and that is going to be equal to 246.96 joule. Now C part of the question says that work done by the net force on the body for 10 seconds. So here net force we found out as 5.04 Newton. So work done by net force would be 5.04 multiplied by 126 meter, and that would be equal to 635.04 joule. Now fourth part of the question D says that change in kinetic energy of the body in 10 seconds. So from work energy theorem we know that change in kinetic energy, work done by all the net forces equal to change in kinetic energy. So it can be expressed as delta change in kinetic energy equals to work done by net force. Change in kinetic energy would be equal to work done by net force, that is this. So 635.04 joule. Thank you.